Questions 9 and 10 refer to the following information. The speed of a sound wave in air depends on the air temperature. So here they're giving you this equation, and A represents the speed of the sound wave, and T represents the air temperature in degrees. Which of the following expresses the air temperature in terms of the speed of a sound wave? Well, if you take this equation, you'll notice that this equation has letter A, or the speed of the sound wave by itself, and here they're asking you for, if you look at all the answer choices, to take the same equation and get letter T isolated. So here we're going to subtract 1052 on both sides. So we have A minus 1052 equals 1.08, 1 and 800ths T. And here to solve for letter T, we're going to divide both sides by 1 and 800ths. So here letter T is equal to A minus 1052 over 1.08, or answer choice letter A. Problem 10 then asks you to take that answer that you just found, and it says, at which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So they are now asking you, which of the following temperatures? Solve for letter T if the speed of the sound wave, which was A, is 1,000 feet per second. So we're going to take our answer that we got in part 9, and we're going to substitute in A is equal to 1,000. You could have also plugged in A is equal to 1,000 back into the original equation, but here this equation already has letter T by itself. So we have A, which is 1,000, minus 1052 over 1 and 800ths. And when you do this division, you get T is equal to negative 48.1, give or take, and that is going to be letter B. Which of the following air temperatures will be closest? Negative 48 degrees Fahrenheit. Problem 3, one end of a spring is attached to a ceiling. When an object of mass m, so letter M stands for the mass, is attached to the other end of the spring stretches out to a length, so L represents the length in centimeters. What is the value of M when L, the length, is 73? So here we're going to plug in L is equal to 73. So I have 73 equals 24 plus 3.5, 3.5 m. Here we'll subtract 24 on both sides. So we'll get 49 equals 3.5 m. And then we'll divide both sides by 3.5. So here m is going to be equal to 14, or answer choice A. Problem 32. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty truck and the driver is 4,500, what is the maximum possible value for X that will keep the combined weight below the bridge's posted limit? So here we want the weight to be below. We want it to be less than the limit, which is 6,000. Here the empty truck and its driver is 4,500 pounds, and then each of these boxes weighs 14 pounds. So 14 is the weight of each box, and it's carrying X boxes. So this particular question is asking you to solve this inequality. Here we'll subtract 45,000, it's going to be 4,500 on both sides. So here we're going to have 14 times x, so 14x is less than or equal to 1,500, and we'll divide both sides by 14. X is less than 107.14, give or take. So it says, what is the maximum possible value for X? Well, X stands for the boxes. You can't have 0.1 of a box, So X is less than 107.14. So it looks like here it could carry 107 boxes and still be under the weight. When you get to that 108th box, that makes the weight go over 6,000. So here, our answer is 107. Number 31, Wyatt can husk at least 12 dozen ears of corn per hour, and at most 18 dozen ears of corn per hour. So on the slow day, 12 dozen per hour. On the faster day, the faster hour, 18 dozen. Based on this information, what is a possible amount of time in hours it could take Wyatt to husk 72 dozen ears of corn? Well, let's say Wyatt's having a slow hour. He can do 12 dozen ears of corn per hour. And in this case, you have 72 dozen ears of corn. So if 12x equals 72, divide both sides by 12, and it would take Wyatt 6 hours to husk the corn. On his fastest day, he can do 18 dozen ears of corn per hour, where there's still the same 72 dozen ears. So how many hours would it take him? If I divide both sides by 18, x is equal to 4. So it takes Wyatt anywhere in between 4 and 6 hours to husk this corn. What is a possible amount of time in hours? So any answer that you would grid in between 4 and 6, I would play it safe and go 5. Any answer between 4 and 6 hours would be correct. Problem 16, the sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses awarded were in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses? So I'll let X be equal to the number of $250 bonuses. I'll let Y be equal to the number of $750 bonuses. And it says a total of $3,000 was given out. So if I take the 250 and multiply it by the number of 250 bonuses, that's 250x, plus if I take 750 and multiply it by the number of $750 bonuses, that's Y. Here my answer is going to be 3,000. But here's where the issue takes place. We have two variables, x and y. That means we need to have two equations to solve. And we don't have enough information to write another equation. The question is just asking, what is one possible number of $250 bonuses that were awarded? So I'm going to take this equation and somehow come up with an answer for, in this case, x, because the question says, what's one possible number of $250 bonuses? This implies one possible. There's probably going to be more than one possible answer. So let's assume that the number of $750 bonuses is 1. Let's just assume that only one $750 bonus was given out. If I take this equation and I plug in 1 for y, I'm going to get 250x plus 750 equals 3,000. If one $750 bonus was given out, let's solve this equation for x to figure out how many $250 bonuses were given out. Here I'll subtract 750 on both sides. So I have 250x equals 2250. And if I divide both sides by 250, I get x is equal to 9. So if I'm taking the SATs, I'm stopping right there. The question said at least one $250 bonus and at least one $750 bonus were awarded. Okay, I assume that there was one $750 bonus. If that was the case, that answers the question, there was at least one, then the number of 250 bonuses is 9. So 9 is an acceptable answer to this question. Now, when you do these grid questions, know that you can have more than one correct answer. 9 is a correct answer, and if this is the SATs, I'm done. I'm answering 9 and I'm moving on. You see how we assume that there was one $750 bonus? if you assume that there were two $750 bonuses, take the equation that we had written, 250x plus 750y equals 3,000. Plug in now y is equal to 2. That's 250x plus 750 times 2 is 1,500. That has to equal 3,000. And now if I solve for x by subtracting 1,500, I get 250x equals 1,500. Or if I divide both sides by 250, I get another acceptable answer that x is going to be equal to 6. So it could have been two $750 bonuses and 6 $250 bonuses. So one answer to the question is 9, one answer to the question is 6. You see how we assumed y is 1 and y is 2? You can assume y is 3, and if you would have plugged in 3 into the equation for y, you would have gotten x is equal to 3. So these are the three correct answers, 3, 6, and 9. If you would have assumed that there could have been 4 $750 bonuses, when you plug that into the equation, 250x plus 750y equals 3,000, what would have happened is 250x plus 750 times 4 is 3,000. If there would have been 4 $750 bonuses, there would have been no money left over for the $250 bonuses. That would have been x is equal to 0. But that's not a right answer because the problem said at least one of each type of bonus would have been given out. So here are your 3 possible correct answers, and all you need on the SATs is 1, 3, or 6, or 9. Questions 15 and 16 refer to the following information. Here we have a graph that shows the total cost C of renting a boat for H hours. So here's the time in hours, so H hours is along the bottom, and C is the total cost. So we have the x-axis is H, the y-axis is C. What does the C-intercept represent in the graph? We're used to this being the x-axis and the y-axis. Now they're just calling it the H and the C, so that way the numbers have meaning. Well, what is the C-intercept? Well, here's our C-axis. I want to know what the C-intercept is, basically where the line hits the C-axis. So this question is asking you, what does this point represent? And that's the point 0, 5. Usually we have x, y is 0, 5. Here we have H and C is 0, 5. So what does that point represent? Well, H is 0. H is the time in hours, so I guess 0 hours. C, the cost, is 5. So this is the total cost of renting a boat by the hour. So it looks like here, what does that point represent? The initial cost of renting the boat, the number of boats, the total number of hours, or the increase in cost to rent the boat for each additional hour? Well, I'm going to go with letter A, the initial cost of renting the boat. Why? Because H hours, 0 hours into renting the boat. So when you start to rent the boat, the cost C is $5. So that's why my answer is going to be letter A. Number 16, which of the following represents the relationship between H and C? And they're giving you 4 equations. And this goes back to, in geometry, when you wrote or you had to write the equation of the line, y equals mx plus b. We have to look at this line that we were given and come up with m, the slope, and b, the y-intercept of the line. Now, we're used to seeing x and y. We don't have that here. Here, our x is h, and our y is c. So the y-intercept is really the c-intercept, or where the line hits the y or c axis. Well, we just did that. Here the y-intercept, the c-intercept is 5. So we already know that traditionally in geometry, the b, the y-intercept, now called the c-intercept, we know that's going to be 5. So y equals mx plus b, I know that b has to be 5. And now I know that letter A can't be correct and letter D can't be correct because these are the only two equations that have the quote-unquote y-intercept, in this case the c-intercept, as 5. I need to figure out what the slope is. What is the change in as the line goes on? I need to know what the slope is going to be. And the slope formula, the change in y, y2 minus y1, over the change in x, x2 minus x1, this is how I calculate the slope. In order to use the slope formula, you need 2 points on the line. Well, we already have 1 point on the line. We already found this y-intercept, this c-intercept, is 0, 5. Now I'm just going to take any other point on the line. Here's another point on the line. This is the point 1, 8. So I'm going to take the points 0, 5 and 1, 8, and I'm going to plug them into the slope formula to see whether the slope is 3/4 or whether the slope is 3. So when you use the slope formula, you call one point x1, y1, the other point x2, y2. y2 minus y1, 8 minus 5, over x2 minus x1, 1 minus 0. 8 minus 5 over 1 minus 0 simplifies to 3. So here I know the slope is 3, which means my answer is letter C.